Hi, welcome back to Decaf-Math ASMR, and a warm welcome if you are new here. Guess I'm welcoming myself back too. It's been a few weeks. I've missed you and I hope that you've been doing well. Today we are going to review, learn, practice, study, fall asleep to, get bored by, fill in the blank. We're going to work with special angles and special values of trig functions. Our main 6 trig functions, namely sine, cosine, tangent, cotangent, secant, cosecant. So those 6, and we are going to work with special angles from 0 to pi over 2, or 90 degrees. So that is the first quadrant of the unit circle. So that would be the upper right quadrant. And we're only going to focus on that region because for the rest of the unit circle, we can use symmetry and we can focus on these main values and reflect them into each other quadrant by just adding some negatives or positives. So we're going to focus on memorizing these values first, and then in another video we can go over how to fill in the rest. So I will be kind of quizzing you. It's okay if you know it. It's okay if you don't. If you tend to freeze up and you've learned this stuff, it's okay. You're not dumb. You're not stupid. I love you. Here, so I'll kind of be quizzing you, but then I'll also be helping. So we're just here to relax. There's no pressure. And if you want to just close your eyes, feel free to do that too, okay? And we're going to work with both degrees and radians. Just mix it up. Okay, are you ready? What is sine of pi over 6? What is sine pi over 6? Sine pi over 6. Sine pi over 6. That would be 1/2. Very good, very good. 1 over 2. 1/2. Pi over 6 is the same as 30 degrees. Pi over 6 radians is the same as 30 degrees. Sine of pi over 6, or sine of 30 degrees, is 1/2. 1/2. If you want to know where these values come from, it's really based on right triangles. That's what makes them special, in that you can use geometry on the unit circle. So 30 degrees makes a special 30, 60, 90 right triangle. And you can use geometry to find the length of the horizontal side and the vertical, which gives you the coordinates of the point on the unit circle. And it just so happens that the x coordinate is going to be cosine and the y coordinate is going to be sine. For now, we don't have to worry about it, but in case you were curious, these aren't just really random angles. They are special ones, and they're special because we can use geometry. So we can go into that in more depth and maybe even go over the proof, but that's why. So sine of 30 degrees, sine of pi over 6 is 1/2. Very good. What is cosine of 0? Cosine 0. What is cosine 0? Very good. 1. Cosine of 0, which could be radians or degrees. 0 is just 0. Cosine 0 radians, cosine 0 degrees is 1. Again, all the points on the unit circle have a corresponding angle. If you just connect the point on the unit circle anywhere, you draw the line to the origin 0, 0. You sweep an angle like this. And 0 is the one that corresponds to the positive x-axis. And so you have a point on the unit circle. In that case, it would be 1, 0. That corresponds to 0 degrees or 0 radians. And the x-coordinate is the cosine of that angle. And the y-coordinate is the sine of that angle. Just due to SOHCAHTOA and the fact that it's the unit circle width. So that's a radius of 1. So the cosine of 0 is going to be the first coordinate, the x-coordinate, which is 1. Good. Cosine of 0 is 1. Very good. What is cosine of 45 degrees? Cosine of 45 degrees. Cosine of 45 degrees. It's another special angle that we can find from geometry. It's going to make an isosceles triangle where two legs have the same length. So coincidentally, cosine of 45 degrees is the same as sine of 45 degrees, which is square root of 2 over 2. Very good. Square root of 2, that whole thing, over 2. The square root first, and then over 2. Or you might have seen it as 1 over the square root of 2. Yep. So 45 degrees is the same as pi over 4 radians. Cosine of pi over 4, cosine of 45 degrees is square root of 2 over 2, which is the same as sine of pi over 4 and sine of 45 degrees, which is also square root of 2 over 2. Very good. Very, very good. What is tangent, take your time with this, tangent of 60 degrees? What is the tangent of 60 degrees. Tangent of 60 degrees. While you think on that one, I will have some water. I will have some water. Tangent of 60 degrees. So, remember that tangent is sine over cosine. Sine over cosine. So tangent of 60 degrees is sine 60 degrees divided by cosine of 60 degrees. So we're kind of quizzing ourselves. It's like a 2-in-1. So we need to know sine 60 degrees, which is the square root of 3 over 2, and cosine 60 degrees, which is 1/2, and we do square root of 3 over 2 over 1/2. And the 2's on the denominators cancel. You can think of that as multiplying by 2 on the top and the bottom. However you like to think about it, dividing by a fraction, you could multiply by the reciprocal. Either way, it evaluates to square root of 3. Tangent of 60 degrees is square root of 3. Now that can be a value that you memorize, or you can just calculate that very quickly through sine and cosine. Remember, we have sine and cosine, and then the other 4 trig functions can be defined in terms of sine and cosine. So tangent is sine over cosine. Cosecant is 1 over sine, and secant is 1 over cosine, and cotangent is 1 over tangent, but tangent is sine over cosine. So cotangent is cosine over sine. And so if you actually know your sine and cosine values, you can fill in the rest of the table for the other values just from that alone. So no need to memorize if you don't want to. Very good. So what is secant of pi over 4? What is secant pi over 4? What is secant pi over 4? Pi over 4 again is 45 degrees. You got it. Secant is what? Secant is 1 over cosine. So what is cosine pi over 4? Pi over 4 is 45 degrees. So that is square root of 2 over 2. Or it might be easier in this case to remember that's 1 over the square root of 2. And secant is 1 over cosine, so 1 over square root of 2. So you just flip-flop it and you get square root of 2. Secant of pi over 4, or 45 degrees, is square root of 2. Very good. Very, very good. Okay, how about secant again, secant of 90 degrees. Secant of 90 degrees. So in my mind I'll go, where's 90 degrees on the unit circle? Or where's the point that's associated with an angle or a theta of 90? So that will be, this is 0, 90 is right at the top, along the y-axis, positive direction. So secant, again, is 1 over cosine. Cosine is the x value of the point that's associated with that angle. So the coordinates of that point on the unit circle is 0, 1, because that'll have a distance of 1. So the first coordinate of that is cosine 90, which is 0, 0. And secant is 1 over cosine. We have 1 over 0. Can we divide by 0 in math? Nope, no. We can't ever divide by 0. So secant is 1 over cosine, and cosine of 90 is 0. We have a 1 over 0, which is a problem. If we thought about it as a limit, if you've learned about limits, if not, it's okay. But if we think about it as a limit, it approaches positive infinity. So we can either say that it's undefined, that secant of 90 degrees is undefined. But if we were to draw the graph of secant, it's going to have an asymptote. We're going to approach positive infinity. It depends on which way we're graphing from, actually, but it's an asymptote there. So, but we would pretty much just write undefined typically. So, very good. So, secant is going to be undefined anytime cosine is equal to 0. And that's the same deal with tangent, since tangent is sine over cosine. If cosine is 0, we have a divide by 0 problem. So that's also undefined at 90 degrees. Excellent. What is tangent 0? What is tangent of 0? Degrees or radians? Tangent 0. Tangent 0 is sine 0 over cosine 0, right? So now we just have to remember which way is which. Sine 0 is 0, so we have 0 over cosine 0 is 1. 0 divided by 1 is okay. We can't do 1 divided by 0. We can do 0 divided by 1. So tangent to 0 is 0. Very good. How about one more? Cosecant. Cosecant of pi over 3. Cosecant of pi over 3. Cosecant of pi over 3. Cosecant is 1 over sine. So really, we just need to know what sine of pi over 3 is. Pi over 3 is 60 degrees. So, what is sine of pi over 3, or 60 degrees? It's kind of like asking 2 in 1. So, but that's the nice thing, is you only really need to memorize the sine and cosine values. So sine of 60 degrees, or pi over 3, is square root of 3 over 2. Square root of 3 over 2. And so therefore cosecant is 1 over square root of 3 over 2, which just flip-flops. So it's 2 over square root of 3. 2 over square root of 3. And if you want to rationalize that, you could just get 2 square root of 3 over 3. But that doesn't really matter. Cosecant of pi over 3, or 60 degrees, is 2 over square root of 3. Very good. So you can draw yourself a table to to just help you memorize. I think 0 and 90 degrees, as far as sine and cosine go, are the most straightforward because you have 0, 1 on the vertical, so that's the 90 degree part, and you have 1, 0 horizontally. You have your 45 degree angle one, which have the two coordinates equal, so it's square root of 2 over 2, square root of 2 over 2, so sine and cosine of 45 degrees are both square root of 2 over 2. And then you have 30 degrees and 60 degree parts, which are symmetric but opposite, so you only really need to memorize one of them. So sine of 30 degrees is 1/2, and I like to think of that sine of 30 degrees as 1/2, so cosine of 30 degrees is the other one, which is square root of 3 over 2. So for cosine of 60 degrees, that's 1/2, and sine of 60 degrees is the other one, square root of 3 over 2. So you can kind of have little tricks for memorizing them, but it's really just those 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So it's your 5 special angles, and then for all of the other trig functions, just memorize how they are related to sine and cosine, and you could calculate them. So I think you've got it. You are more than ready. Come back, review if you need to. We can come back and actually prove those values, do a little picture, work with the geometry. But I hope that this was everything you needed it to be, whether you're asleep right now, bored to death, or relaxed, or having fun. Thank you for hanging out with me. I will see you again very, very